Sounds great.
Okay, have a great session.
All right, thanks for having me. Well, hello everyone. This is an awesome format. I love lightning talks. I think that lots and lots of fast, succinct, get to the point sessions is wonderful. So this is great. So this is all about calendar tables. It's a tool. It is it's an interesting tool. If you've used them before, you get them. You know why they're useful. You probably like them. If you've never used them before, this is great. We can learn about them and play with them. So this is me. I've done a bunch of stuff, but you're not here to hear about me, and we don't have a lot of time. So my Twitter is here, at Edward Pollack. Feel free to find me if you'd like to, ask questions, give me ideas, things you've done, tell me this is good or bad or whatever. Great. So what are we going to do here in 10 minutes? We're going to define a calendar table, briefly talk about what it does, and then basically finish in demos with a little bit of wrap up at the end. And that's it. Super simple agenda. It's the beauty of how this works. So what is the thing I'm talking about? A calendar table. Why am I here talking about it? And what it really is a simple table. It can be in any data format you want, any database format or technology, where a row is a date, and you have lots of them. And all the dimensions on that row are components of that date. Days, weeks, years, the name, a string, the first day of that month or that week or whatever. You can have lots and lots of these derived metrics. And what this is for and why this is cool is that it eliminates lots and lots of on-the-fly, scary, crazy math. And we've seen this before. We've seen crazy code, both code and T-SQL, where people are doing all kinds of date parts and date diffs and all kinds of crazy math to figure out stuff like, I want all the orders from a certain quarter in a certain year, or everything from like Fridays. And the moment you begin doing that, your code gets complicated. It gets scary. It's hard to read. It's hard to maintain. It can be slow, and it's easy to make mistakes. So because of that, this is a great tool to simplify all of that and make our lives easier. This can be used in many, many areas. It's most often found in analytics and reporting, but you can pretty much use it anywhere where lots of date manipulation may go on. It's an inexpensive way to do it, and ultimately what you're really trying to avoid is this. We've seen things like this before. This may be better than some of the things you've seen, or it may have been worse than some of the things you've seen in the past. But ultimately, you look at a code like this and think, I don't know what's going on. I can figure it out, but it's going to take a minute or two because it's really ugly. That's what this is. It serves a function, but it's ugly, and it's hard to read. And I don't know if it's correct or not until I really think about it a lot, which is the recipe for code that will be hard to maintain, hard to deal with, that will perform poorly and make our lives miserable as the people that are forced to deal with this. So a lot of the rest of this is going to be demo, and we're going to show what it is, how do we use it, and why is it cool. So here is all this I'm going to share later. So you'll have it. I will share it with the people running this conference as well as on Twitter. So you'll have it. Basically, I'm going to create a table, a calendar table. You'll see the only real key here is the calendar date. It's a date, primary key cluster, done. Everything else in this table is dimension off of that. You know, the name of the day, the month name, the last date of the quarter. Is it a holiday? You can put really anything in this. And that's the beauty of this. You can really put any metrics you want in this, any dimensions you want. There's no real limits. It's really what you need, what your organization needs. If you don't need it, you can take it out, though it isn't very expensive to have it. And then I made a proc that just basically loops through day by day and will assign all these different metrics to that calendar date and insert the date and loop through. You may say, hey, a loop, that's really slow, but we only do this once. The beauty of something like this is you build it, you populate it, and then you're done. And that's wonderful. And so if you don't have to actually keep playing with it all the time, it becomes a source of truth for you rather than something you have to deal with later. And so there's a whole bunch of holiday logic in here, but you really just do this one time in one place, and you're done, and you populate it. In this case, I've placed in 120 years of data. It took about 2 minutes. Sounds like a lot of data, but it's really not. 120 years is about 43,000 days, and a table with 43,000 days is not very scary. So some calculations are complicated, though. A great example is Easter. I was asked once to put Easter into a dimension for this, and I realized calculating Easter on the fly without just going out and grabbing all the Easters off of a database somewhere is hard. There are many algorithms for it. One of the more famous ones, Gauss's algorithm, and this is not simple. It requires a whole bunch of variables and a whole bunch of math. And realistically, I never want this code to ever appear inside anything I do. I want this encapsulated into a function. That function will do all the work for me. And then if I ever need it, I will say like, oh, give me Easter for 2019. Or, hey, give me Easter for 2058. The ideal case is just put it in the calendar table and never do any of this again. Anything complicated, anything that's error prone and messy, you want to do it once and never do it again and have that be your source of truth in your application. So now I'm just going to demo how all this works. So here's our query from earlier. We don't want things that are going to look like that. What we're going to do, though, is take a look quickly. So here is our current month of data from this calendar table. Here's what you see. June 1st all the way to June 30th, and you can see the data in here. Nothing surprising, nothing honestly that complicated. There's a holiday in there, Father's Day, yay. Weekdays, business days, previous and next business days. Some of these things are a little hard to calculate, but it's all here. It's all correct. Days and month, for example. It's all here, ready to use. And if we were to look at the contents of the table in aggregate, we'd see 43,000 rows, 120 years. Not that big of a deal. Cool. And the beauty of this is like 4 megs. This table is like 4 megs. It's really small. So we can simplify code. Here's some real world kind of examples of things you might do at some point, and you've made them scarier stuff, where you can simplify. So here, I want to get all the orders from a certain quarter in a certain year on Thursday and Friday that are not in Thanksgiving. This may sound kind of esoteric, like why would anybody do that? But if you're familiar with analytics and reporting, people are constantly asking questions that get complicated because they want to solve complicated problems. Complicated problems involve complicated solutions. And so here's our query, and this query works, but it's hard to read. You can see this a whole long string here of date parts that are kind of hard to figure out what they're doing. You can read through them and figure it out, or I can replace that with the calendar table solution. And this query gets the same results. And in the end, though, what I have is something easy to read. Calendar year, 2013. Calendar quarter, 4. Day name, Thursday, Friday, holiday name, not Thanksgiving. Now, I didn't index any additional columns in this calendar table, but you can do that if you want. Once you know what your common queries are, you can index and make them super fast if you need to. We can generate date ranges too, which is kind of a cool function. A common thing is to take a span of time and then assign values to wherever data is. But if data doesn't exist for a day or a unit of time, you want a 0. So I want to take this here pile of order data, which is only 12 dates, and plop that up against a year. Well, how am I going to do that? With the calendar table, I can just say select from the calendar table where the year is 2013 and left join my order data into it. And then I get a beautiful view here of data where I have mostly zeros when there's no orders, but then when there are orders, they pop up in there. So you can generate a date range kind of like a numbers table, like a tally table, in a very similar fashion. And you can keep doing all kinds of cool things like this. For example, I want all the sales in 2014 that did not occur on business days. Easy. Run a query, business day 0, done. There they are. I could group data by year and quarter. Normally this could be kind of messy. Here I just group by year and quarter, and I'm done, and there it is. So a lot of these calculations that are normally kind of messy, kind of complicated, get simpler. I can do it. I have a baseball database that I maintain, and we can do very similar things here as well. For example, I want all the baseball games that ever occurred in the history of baseball on Easter, and this is publicly available, this database, by the way. If you want it, let me know. And oh, right, we've got to use this database because I have a different dim date there that has more years in it. There we go. This one has to go back further. I have to go to the 1800s because baseball is old. So this dim date table has 300 years of data in it. Cool. There you are. All 559 Major League Baseball games in the U.S. that ever occurred on Easter. Poof. Just like that. What if I wanted all the weekday games in 2018? Is weekday 1? Calendar year 2018. And there's our results. This can be done in any sport. It really doesn't matter which. You can do it on football. You could do it on basketball. You could do it on hockey, whatever. Total runs scored in games that occur on Wednesdays at night, but not in a holiday. It sounds complicated, sounds ridiculous, but with the calendar table to solve this problem, it's a few lines of T-SQL to get added on as a where clause. And we find there's all the runs ever scored in this strange calculation over those games. And I could also say, hey, I want total runs scored on Wednesdays, nights, and holidays. Sure, why not? Complicated and weird, but why not? We can keep doing things like this. Like I want the holidays and the runs per holiday. There you go. All time Wednesdays and night on holidays, there's your runs scored for each holiday. Or if I wanted to know how many runs were scored in total on all holidays ever in the US, there we go. And we can see, and obviously they correlate a bit to the time of year, warmer times of year as opposed to colder. So I can go on and on with the examples here, but you can see that this simplifies querying very significantly, turning complex date math into simple lines of T-SQL. So how does this all help us in the end? If it isn't obvious from seeing it, it makes our code easier to read and it makes it more maintainable. The maintainability is huge. You don't want the same code repeated over and over and over throughout an application because then you're forced to maintain it in many places and it becomes error prone. Encapsulating all of your calendar logic in one single place in a table populated by a single proc, there you go. It's simple, it's straightforward, and you can standardize everything. If your business, if your organization has important logic, you can standardize all of it and run with it and never need to do this again. So ultimately, this provides you a source of truth and a way to have really important things in one place and simplify your code. And the fun crux of all this is it doesn't cost anything. It doesn't cost licenses or software or hardware, and it's very inexpensive. The 300 years I showed you is like 10 megs. It's tiny. So this is a fun tool. It's very useful, and I hope you find it useful too. And that is 10 minutes.